All right, so the first couple that we looked at were just initially basic trig equations. So now we're going to get into some that you actually have to manipulate a bit to get them into that basic trig equation form. All right, so the first two here, 2 cosine theta minus 1 equals 0 and tan squared theta minus 3 equals 0. So what you're doing with these is you're just at the beginning treating the trig function like it's the variable that you want to isolate. So you want to try to isolate cosine theta. You want to try to isolate the tangent of theta. So how would you isolate the cosine of theta? You would just add 1 and divide by 2. So then you're going to get cosine theta equals a half, right? So you're basically just solving first for cosine theta. And then once you solve for cosine theta, you have to think about, all right, well, which angle has a cosine of 1/2? Well, the angle that has a cosine of 1/2 is pi over 3, right? So the theta bar is pi over 3. But then I would go to my ASTC and I would realize that, okay, I have my solution that's in the first quadrant, so that's my pi over 3, which is my reference angle, but I also need the solution that's in the fourth quadrant. So pi over 3 in the fourth quadrant, the angle that has that as a reference angle is actually 5 pi over 3. Okay, so then the two solutions are pi over 3 and 5 pi over 3, right? So those are your solutions in 0 to 2 pi, but then you have to add 2 pi k to your solutions to get the general solution, because again, it's just the idea of you keep wrapping around the circle, or you keep going through a period of the function until you get back at the same solution. So here your solutions are pi over 3 and 5 pi over 3 plus 2 pi k. And then with tangent now, the only difference with tangent one here is, yes, we add 3 to both sides and then we take the square root, but if we recall, when we take a square root, we have to take the positive or negative square root, and actually with tangent, radical 3 was one of our trig wheel values. Remember? So when did we get radical 3? Remember how we had set up our table for the tangent? At 0 it was 0, at pi over 6 it was square root of 3 over 3, at pi over 4 it was 1, and at pi over 3 it was the square root of 3. So this is where we are. We're at this angle. So our reference angle is pi over 3, but then remember what we did, since tangent was an odd function, if we put a negative in front of each, we get our other solution, right? Because it's the positive or negative square root of 3. So one solution is going to be pi over 3 plus pi k, and then the other solution is going to be negative pi over 3 plus pi k. Okay, and again, that we were helped out by the fact that tangent is an odd function. All right, so there they give us the two solutions, right? Pi over 3 and negative pi over 3. That's in the interval between negative pi over 2 and positive pi over 2. But again, if we want our general solution, we need to add pi k to each of those. All right, so we end up with pi over 3 plus k pi and negative pi over 3 plus k pi. So far, we've been doing ones that were trig wheel values, right? For the most part, I think we had a tangent one earlier that wasn't, but for the most part, they've been trig wheel values. So what if they're not trig wheel values, right? Like 0.3 and negative 0.8, these are not trig wheel values. So what we need to do to solve these is we need to take inverse cosine of both sides, right? So if we have the cosine theta equals 0.3, if we take the inverse cosine of both sides, we end up getting that theta equals the inverse cosine of 0.3. So then we punch that in the calculator and we get 1.266. And again, this is going to be periodic, so if we want our general solution, we'd have to add 2 pi k to this. So that gives us one solution, which is good. But remember, inverse cosine only gives us one value because it's a function. We also then need to find this second value, okay? Because here the inverse cosine gave us the solution that's in the first quadrant, which is 1.266. But if we want the angle that corresponds to that in the fourth quadrant, then we have to go back to our rules. Remember how we had the different rules? If we knew what the reference angle was in the second quadrant, we would do pi minus the reference angle. If we were in the third quadrant, we would do pi plus the reference angle. And if we were in the fourth quadrant, we would do 2 pi minus the reference angle. So our solution in the fourth quadrant is actually going to be 2 pi minus 1.266 plus 2 pi k. So if we want to get approximation of that, we can just do 2 pi minus the answer, and it'll give us 5.017. So our other solution would be 5.017 plus 2 pi k. But again, personally, I would take it as 2 pi minus 1.266 plus 2 pi k, because, you know, they're just approximations anyway. So that's how you would do part A. Now B is a little bit more complicated, because B, you have a negative value of the sine. So we would start out the same way, right? We do the inverse sine of both sides, So we get theta equals inverse sine of negative 0.8. So this one is easy. It gives us negative 0.927. So this is negative 0.927. But again, we want the general solution, so we do plus 2 pi k because the period of sine is 2 pi. So that gives us the first one. But if, again, remember, when you're dealing with inverse sine and we have a negative value, it's giving us this value. So what it's really doing is the angle that we got here is this, which is negative 0.927. So that's the fourth quadrant angle, but we also need the third quadrant angle, right? Because that's the other quadrant where sine is going to be negative. We have the one in the fourth quadrant, but we need the one in the third quadrant. So we realize that if the solution was negative 0.927, that means that the reference angle, theta hat, is positive 0.927. And then we can just use our rule that this angle in the third quadrant is going to end up being pi plus 0.927. So that's going to be our third quadrant angle. So our other solution in this case is pi plus 0.927 plus 2 pi k. And again, if I want to punch it in the calculator, I can. And it would give me 4.069, right? So 4.069 plus 2 pi k. So there's my other solution. So you'd want this one and that one, right? And over here you had this one and that one. But again, I would take it in the form with the 2 pi and the pi in it also, either way. And then you can, of course, check these on the calculator if you wish as well. And so then just one last one, tan of theta equals 10. So same idea, we would solve this by doing our inverse tangent of 10, and that's going to be our solution. But again, luckily with tangent, we only had to worry about one solution per period. So if we do inverse tangent of 10 on the calculator, we get 1.471. But again, the period of tangent is just pi and not 2 pi, so we just do plus pi k, and we only need to find the one solution. So that was the thing to keep in mind, right? With tangent, there's only one solution for each value, and you just tack the plus pi k on the end of it. So let's graph this and actually check it on the calculator, right? In this one, I had to actually move way up. So I have my two functions, y equals tan x and y equals 10, but I had to, shift way up here, and there's my intersection point, which is 1.471, and that's what I got on my calculator as well.